Welcome. Today, we're diving into the essential security practices for Docker containers. This is your guide to securing containerized applications through proven practices and defensive strategies. It's all about making sure your containers are safe and sound. Let's explore some common security threats that containers face. First, we have image vulnerabilities. This includes outdated base images, known common vulnerabilities and exposures or CVEs in packages, and even malicious image layers. Then there are runtime attacks, which can involve container escape attempts, privilege escalation, and resource exhaustion. Knowing these threats is the first step in defending against them. Now, let's talk about securing base images. A key practice is to use minimal base images. Here's an example of a Dockerfile using a minimal Python base image. We update the package lists, install only the necessary packages like curl, and then clean up the package list to reduce the image size. We also switch to a non-root user with user ID 1000:1000, set the working directory, copy the requirements file, and install the Python dependencies using pip. Some key practices include using minimal base images, regularly updating your images, scanning for vulnerabilities, removing unnecessary packages, and using official images. Configuring your containers to run as a non-root user is crucial for security. Here's how you can do it in your Dockerfile. First, create a non-root user and group. Then, set the ownership of the application files to this user. Finally, switch to the non-root user within the container. Additionally, you can drop capabilities using Docker's runtime options. This prevents the container from performing privileged operations. Some key security principles include never running as root, using specific user identifications or UIDs, dropping unnecessary capabilities, setting file permissions correctly, and applying the principle of least privilege. Isolating your containers in terms of network and resources is another essential security measure. You can create custom bridge networks to isolate your containers from the host network. Additionally, you can set memory and CPU limits to prevent resource exhaustion. You can also make the file system read-only and use temporary file system mounts for sensitive data. Also, expose only the necessary ports for the container to function. Here's an example of creating a custom network and running a container with network restrictions, memory limits, CPU limits, a read-only file system, and a temporary file system mount. Some key isolation controls include custom bridge networks, memory and central processing unit or CPU limits, read-only file systems, temporary file system mounts, and port exposure control. Regular security scanning and monitoring are vital for maintaining the security of your containers. Tools like Docker Scout and Trivy can be used to scan your images for vulnerabilities. You can also monitor the runtime behavior of your containers using tools like Docker Stats. Finally, perform regular security audits to identify and address any potential security issues. Here's an example of using Docker Scout and Trivy to scan images, monitoring runtime behavior, and performing a security audit. A good monitoring strategy includes automated vulnerability scans, runtime behavior monitoring, resource usage tracking, log analysis and alerting, and regular security audits. Properly managing secrets and configurations is crucial for container security. Never hardcode secrets in your code or Docker files. Instead, use external secret stores like Docker Secrets or Vault. Mount secrets as files in the container to prevent them from being exposed in environment variables. Remember to rotate credentials regularly and limit the scope of access for each secret. Here's an example of using Docker secrets, environment variables, and external secret management. Some best practices include never hard coding secrets, using external secret stores, mounting secrets as files, rotating credentials regularly, and limiting secret access scope. In summary, here's a security checklist to help you secure your containers. Use minimal base images, run as a non-root user, implement network isolation, scan for vulnerabilities, secure secrets management, and monitor runtime behavior. Here are some steps to implement these security measures. Audit existing containers, implement security policies, set up automated scanning, configure monitoring tools, train development teams, and conduct regular security reviews. Remember, the goal is to build secure, resilient containerized applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.